Welcome back to School of Physics. Today in this lecture we are going to discuss about the accelerated frames, the frames of references which are accelerated with respect to some another frame, and the result of that there arises a force which is called the pseudo force. We will discuss those very forces also. So today's lecture will be all around the frames of references. So first of all we will consider two frames of references. One will be the inertial frame of reference and another will be non-inertial. So consider two frames of references. Okay, let these be S and S prime, and I will draw it down here. Let this very frame of reference be, and it is two. I am discussing all of this stuff in two-dimensional only, because later on it will be applied in the same manner for 3 dimensions also. So this will be frame of reference S, and another frame of reference will be like this very frame of reference. It will be S prime. What does that mean? We are considering two frames of references S prime, while this very S prime, this frame of reference is inertial frame of reference, and this very is non-inertial. Okay, what the inertial frame of reference and non-inertial mean? Now it is inertial frame of reference means that very frame of reference in which the Newton's law of inertia is followed. That means simply this very frame of reference, it follows law of inertia, and you have already seen, and you might be well aware about the law of inertia as you have seen in the first few lectures. So, and the non-inertial frame of reference, in this case this law of inertia is not followed, that is not valid. Law of inertia not followed. So we have considered the two frames of references. One is inertial frame of reference and another is non-inertial frame of reference, and we have to discuss a particle, a body, which is under force, or maybe in the absence of the force, what kind of dynamics that body observes and that body follows in both of these references, with respect to this very reference and then with respect to that very reference. Okay, so consider a particle, a body here, a particle inside this very frame of reference, and ultimately that will be also in this frame of reference, because these are two observed, these are two, like this is origin of this, and this will be O prime, the origin of second reference. So there will be the observers observing this event which is happening with that very body at two different frames, at two different origins. Okay, so consider a particle here, some particle P, okay, and the particle is at a position vector from the inertial frame of reference. It will be at a position of R. Say this is the position vector R with respect to frame of reference S, and with respect to frame of reference S prime, its position vector will be given as this R prime. Okay, but here is another thing. This origin of the frame of reference S prime with respect to S, it is at a position R, capital R. Okay, so that means S R prime is the position vector of O prime with respect to O, that is S prime with respect to reference reference S. Okay, this is the position vector, or the position vector of this very point particle P, position vector of P with respect to O, that is the frame of reference S, and R prime is the position vector of P with respect to this very origin, that is the non-inertial frame of reference, that is O prime. Okay, get these things in mind. R prime, sorry, this is R, capital R. Capital R is the position vector of O prime with respect to O. Fine. R is this very position vector and R prime is this very, that is with respect to O prime. Fine. So applying this very thing, it will be seen like this, like this, like this. This is the point P here. This is O here, and this is O prime. Fine. So it will be this vector will be like R. This vector will be R prime, and this vector is R. Okay, and you have you might be already aware about this very thing, the triangle law of vectors and the addition law. Okay, from that very law you can easily see that this vector plus this vector, that is summation of vectors which are heading in the same direction, that is the this very tail of one is touched by the arrow of the other. These two get added, and that addition of these two vectors is equal to the third, which is in the opposite direction to these kind of things. Say here we are moving from this very position to this, then in the same direction here, but when we move from this very point to this, the arrow gets reversed. Okay, so it is simple to recall that here R, this very thing, R will be equal to the addition of these two vectors, that is R plus R prime. Okay, this is from the law of addition of the vectors, addition law of vectors. Fine, that is the addition law of vectors. So that means we will be having the position vector R, that is this very position vector R, will be equal to this R, that is the position vector of O prime with respect to O, R plus the R prime, that is the position vector of P with respect to O prime in the frame of reference non-inertial. So this will be from addition law of vectors, fine, which is discussed here. So now we are concerned with the acceleration of this very particle, whether it is acted upon by some force or not, because from the second law of motion we know that if this particle is acted upon a force, then ultimately that will definitely cause an acceleration inside that body, and if the acceleration is zero, is not observed, that means the force is not there. So we have to observe this kind of stuff here, that whether the force is applied onto this body or not. So to get that acceleration, we know the acceleration is the double differentiation of position vectors. So with respect to this O, that is the inertial frame of reference,